DHCPv6-PD support?
Yeah, because as I said during the opening, this has created quite a lot of excitement among enterprises, and I had an opportunity to discuss this. And so let's look at the enterprise view. Thank you, yes. So this is just what I gathered from some discussion, and people might agree with not, that's why we are here. It's just to stir some thinking about this from a different perspective. One thing I have noticed is that because I always worked for an IT company or IT-centric company, technology company, I live in a tunnel. I didn't see how the real world outside, where IT and technology is not the core business, how it actually leverages the network and what all lives on the network, okay? So one first thing that was quite surprising for me when I started discussing it, bear in mind, this is actually available only for devices that are registered in the Google Play Store. Now think about everything that uses Android. Those are not devices, that's not your mobile phones, which are regularly managed by your Google Play Store, you get regular updates, etc. Those are all your different IoT devices, be it from different logistics scanners, robots that move stuff around the warehouses, sorters, anything that, smart cars, most of them actually are running Android. If you are running devices in your network that are using Android, but they are not managed by Google Play Store, you need to make sure that you manage the software lifecycle on these devices. And if your vendor, because often these devices are are deployed, are used, they come with a version, they're hardly ever upgraded, or it's a many years long project. So you need to work with your vendors to make sure that they actually incorporate this functionality, which is now in the core of Android, that it will be available for these devices, okay? So that's a very important thing, because we say, oh, it's now available, so everybody's gonna get it. We need to think much broader beyond Android mobile phones, okay? Second thing is the /64. And while the advantage is that now we have visibility of the device, the Android device has a full /64, so no matter what IPv6 address itself configures, there will be always the same /64 that it received, at least for some time, for as long they have the prefix. The problem is now what it means for enterprises and the network architects who worked very hard with their teams on their IPv6 addressing architecture. Now they have to basically rewrite it, right? Because you need a significant portion of your IPv6 address plan dedicated just to these Android devices. And now you think, oh, it's a few hundred phones in an office, what's the problem? Could be thousands, tens of thousands. If you have got a large campus, large logistics center, large hub somewhere, you could be talking about tens of thousands of these Android devices that now potentially could have /64, and you need to basically make sure that your IPv6 address plan can cater for that, okay? Enterprise routers and switches. Well, prefix delegation is a common thing for service providers' equipment, and the CPs, it's well known and understood over the years. On the enterprise side, this is a very novel thing, and Richard mentioned it as well. The RFC is from June this year. So if you think about the whole ecosystem, everything to deploy this in an enterprise has to come together. So it's the devices that, the individual end user devices or the IoT devices, whatever have you, your network infrastructure must support it as well. So this all has to come together, and yeah, it's like with different things. We remember the RFC 8106, which is the DNS information carried in a router advertisement. That took years for major vendors to actually deploy that. So again, if you're an enterprise and you are thinking about using this, you have to put some pressure on your vendors. And now think about a global enterprise with presence in every country in the world. They have different telco operators that are actually managing those networks for them, and they don't have complete control on what vendors are deployed to support their infrastructure. They could be working with every possible network vendor in their network, right? So like universal support across all the vendor routers, layer 3 switches, that's also very important need to take in mind. So in my opinion, this actually is going to be a solid, yeah, the PD is the October, and then the P flag, the signaling that's available only now from June. And then one final thing, think about that /64 in your routing table. So are your MikroTiks, all the smaller routers, not with large capacity, how many of these /64s they can carry. You potentially are looking at an upgrade of your routers if you want to really support a large deployment of these Android devices. So that's just a food for thought, because there is an announcement and we need to dissect it and think about how it applies to a particular scenario, you know. So there's a lot that need to be thought about and actually come together to support it in really in an enterprise environment, which has got a very heterogeneous network infrastructure and also the clients. Rich already mentioned the RFC 9686. Some are welcoming it. Some are thinking, I'm not sure if I want to really trust the device, because today we don't trust the device. What is the zero trust networking, right? Everybody is talking about how untrustworthy our end devices are. So, right, how are we looking at this, and how is this going to impact the security? And also, I would like to call out Ivan Pepelniak. He wrote a nice critical blog. I'm sure some of you know his name. Many of us have learned from him 20 years ago about networking. So I would just to broaden your mind, read his blog about this too.
Thank you, Veronika. Any questions? Any questions? Observations, thoughts? Ah.
I don't know, it's a question of precision. On the slide, the precedent slide, you write need to allocate between 48 to 52. Why is big delegated prefix by Android device?
Yeah. Well, no, that's in your addressing plan. You need to have enough space for your Android devices. So if each device is getting /64, you need to have large enough, allocation within the plan to cater for these devices. I'm talking about all these IoT devices that can be running Android, and you can have thousands, tens of thousands of them within a location. I know this is not what we usually see as in technology companies.
How it will be used?
Well, how it will be used, like within /48, you've got how much? 65,000, thank you.
Yeah, because, for example, we have a /60, it means 16 /64.
That's at home. That's only 16 devices. That's only 16 devices.
16 network behind.
No, but the Android takes the whole /64 now, right? So you don't allocate an address. You are giving them a whole prefix. So you basically are now looking at a much shorter address space. Yeah. No, so you basically need to have, within your addressing plan, you need to make an allocation reservation that from that pool you can allocate enough /64 prefixes to these Android devices, because each Android device will use a single /64. One phone, yeah. So to support thousands of devices, you need to have big enough reservation in your address plan.
Okay, for the whole pool.
Yeah. Yes, yeah. That's it. Yes. Yeah.
So I think that we will see the same in the IPv6 mostly implementations, that we get 164 per device. So I would recommend that you plan today for this.
Yeah.
I do this with my customers to make sure that they are future-proof, and this can be a lot. I was on a large industrial production plant in Germany, and I said, okay, let's take away a 64 per client, and they said, okay, then we need two 48 networks, because they have more than 70,000 devices on the production side, but they have enough addresses. So plan today for a 64 per device, and the same is true for the mobile providers. If you give them out 16 /64, then they can address one network, let's say for the whole family, and then another 15 devices. And if you count them up and start with the refrigerator, 16 devices is not that much.
You don't even have to have
we have got our fridge does not have IPv6 today, it has no IP, but we have new device, this Thermomix, and this is active in the wireless. We have solar power on the roof, and we have a battery, and the battery has an IPv6 address. When does your washing machine have an IPv6 address? So this is the future. And
Well,
then you have 16 devices, so maybe you think about changing your deployment and giving out a 56 per customer.
Currently, it's only 1/64 where you have all your devices.
Yeah, but if you do this...
In the same segment.
Yeah.
Yeah.
In each segment, you need 1/64. It's a question how much segments.
One segment per device. If you do prefix delegation, one segment per device. And if you have 16 devices, and the future is having everything connected, including your dishwasher.
Oh dear.
Yes, this is the future, isn't it?
I'm gonna put up a huge firewall, you know. I don't want my Thermomix cooking for me over IP. But no, the point is also like, for example, even in my home, we don't have any of these connected devices, but you've got the access points, you've got like multiple devices per person, you know, 3 to 4 devices per person, laptop, iPad, iPhone, you know, whatever have you. So yeah, that's just gross.
I would suggest that this really means that ISPs that decided to give out /56s are probably going to have to change to 48s because the number of IoT devices means that 256 is not a safe number, even in a non-massive home. But that also means RIPE will need to stop giving people a hard time for how large an allocation they need.
Well, you're getting /29, right?
Beyond 29.
Beyond 29, true. But yeah, and I agree with you, Wilhelm, absolutely. Like, good addressing plan, there is always reserve, right? However, imagine a networking team who has done lots of hard work and eventually came to some agreement in a very large organization. They finally agreed to have some IPv6 addressing plan, and now you tell them you have to redo this work again. They're going to wait for a little bit, you know. So it's just, I wanted to give you another perspective, you know, what can happen from the enterprise perspective. Yeah.
Hi, James Rice, Chip Network. Hello? Sorry, is this on?
Yes.
James Rice, Chip Networks. It's sounding like with the increase in space given per household now, that maybe what we actually need to look at now is IPv6 NAT.
Hang on a second. Hang on a second, guys. Don't pretend you are such purists, right? Okay. No, honestly, that's hypocrisy because we don't like it, and I agree, yet it's widely used, NAT6s, for symmetric routing. A lot, and we don't talk about it, but it is what it's used. But it is not the same as the, you know, NAT4.4, so. But it's just, okay, let's not pretend we are any better than others because we're exactly the same.
I think one thing we should say is this is a feature that Android has where where you want the DHCPv6-PD feature. You don't have to support it. It still supports Slack. So depends on the environment.
Then you've got the problem that Tomáš from DHL mentions, you know, with InfoSec, and they are looking for visibility. So there's like, you know, how do you balance that, right? David.
Just a really quick one. We mentioned about the addressing plan, and something that's almost come up in the discussion that we've just had is that if you are creating an addressing plan for IPv6, account for future use cases or make sure that you've got a range that, you know, you're not just capping out straight away. Make sure you've got that extra space available, you know, for things that come in the future. Because otherwise, you're going to get stuck and realise we're not got enough space. You know, we need a larger prefix, whatever else. So account for that, and your security teams will thank you for it when it comes around to it.
Okay, I'm seeing 2 more questions that will...
2 more comments. Very good. I like this. 3, Tobias at the back.
I'll come round to Tobias first.
Hey, so Tobias Siewich, MPI Inf. One thing that I would like to really highlight, because we have been like swapping between 60, 64, etc. Whatever you do, even if RIPE gives you a 29, do not break the nibble boundary in your addressing plan.
Yes, correct. I repeat, do not break the nibble boundary. That's correct, yeah.
Does Apple iOS support DHCPv6-PD, or do you have to treat different devices differently, or run Slack for both?
I'm not aware of this. If somebody here in the audience can help, but they support DHCPv6, you know, the network address, the option. So,
Okay,
so I don't know if they do PD. You would have to look up. I never looked.
Don't believe that currently does PD. Maybe for the tethering, but not.
Sorry, say again, Graham.
I think it doesn't do it for normal addressing. It might do it for tethering, but.
Okay.
Hi there, Terry Froy, Spilsby Internet Solutions. It's an observation, but also a bit of clarification for everybody in the room based on everything that's been presented on DHCPv6-PD and Android today. It was, having been one of the commenters on Lorenzo's infamous bug report, well, the bug report assigned to Lorenzo, the argument that he made was not about the device being able to have multiple addresses. It was principally about the fact that without prefix delegation, it broke device tethering to an Android device, because a device that, because even though people said, you know, well, it's Wi-Fi, who would want to tether behind a Wi-Fi device? You tether using Wi-Fi. But it was pointed out that you can USB tether to an Android device, and you lose that functionality over V6, because a V4 device, this would obviously just use NAT. So on that basis, surely a device receiving a single /64 would not actually be sufficient. The /64 would be fine for the device to generate and use addresses for its own purposes, but for a device to sit behind the Android device over USB, it would need actually more than a /64, potentially.
Because it's a CP, basically.
A /60 if you want to abide by Tobias's recommendation, which I do endorse, which is to assign on a nibble boundary. But then if you're assigning a /60 to out of a customer's /56, you run out very, very quickly.
Yeah. So it's kind of like a mixed, right? That's why I brought it up here. Is Nick at the back? I like this, you know, more discussion.
So we've brought up the concept of tethering. So what I know about tethering is that, you know, you have the concept of a router and you have a concept of a LAN. If you have the concept of a shared LAN, you don't need to give more than a /64, because you can do duplicate address detection. So if you've got the concept of a router that's managing that environment, you don't need every device to get a /64. So, you know, the idea that the fridge and the microwave and the washing machine, you know, they're all going to be on separate /64s. It depends how you want to network them. If it is USB and there is no duplicate address detection on that environment, then yeah, you might end up in that situation where every link is becoming independent. But if it's shared like Wi-Fi tethering, then you don't need to do that. And it's all about thinking about, where's my gateway? Can I identify that gateway on the shared network and get out? And so you need enough addresses to make that possible. Not enough addresses to make, you know, everything's a network.
Yeah, I think it's kind of like mixed, like, because if you read the original blog post by Lorenzo, it's the blog post, and also I think the announcement in the ATF mailing list, it's kind of like mixed. It talks about tethering, then it talks about giving V6 addresses to virtual machines on your Android devices, because it's how the apps run on Android. I never knew that because I'm an Apple person, so sorry about it. But yeah, it's kind of like there are different ways how they are trying to sell it, but I don't think it's completely clear, you know, where, anyway.
I just wanted to just to note that, you know, within V6 we can do forwarding to link local addresses. So we don't necessarily need to subnet GUA addresses to be able to provide routing from behind a single.
It's another good point. Yeah.
UE.
Great.
Okay, that was some.
Guys, you generated more questions and debate than my talk was. You know, that's great. I love it.
That was a lot of discussion. Thank you very much, Veronika.
Excellent. Thank you.
Thank you.